Okay, for all of you who are on Zoom, I'll be with you in a couple minutes. I'm just finishing setting up in the classroom.
Dr. Bandager, while you're setting up, do you mind if I ask you a few questions?
Okay, for my Zoom folks, can you uh, uh, can you hear me? Can you raise your hands? No one can hear me. Good. Got one. Emery, I just saw your chat message. I need to get going, but feel free to ask me after class, okay? And in the future, you can definitely ask questions while I'm setting up. All you have to do is unmute yourself and ask the question and I can hear you, okay?
I did
So
actually.
generally, I can't monitor chat while I'm talking, so, or setting up. So just unmute yourself, ask the question. I should be able to do it while I'm setting up in the future.
Can you
Okay.
hear me now, though?
Second thing I'm going to do, I'm going to share my screen. And again, I'm going to ask everyone who is a participant to raise your hand if you can see my screen. No one is, okay. Good, I'm getting some that can see my screen. Yes, no? Looks that way, okay. Unless I hear otherwise by one of you speaking up, I'm going to assume that you can see my screen right now. And we can get started.
Hello.
Yep, I'm here.
Okay, so you can hear me now?
Yes.
Okay, I was actually unmuting myself earlier and trying to speak, but it didn't seem that you heard me. I was just trying to ask about homework questions. Not actually how to do them, but turning it in and due dates and stuff.
Yeah, go right ahead. Ask the questions.
Sure. So you have different due dates on Canvas and on your personal website.
That's because, yes,
Um,
okay, so the question, just like, question is, I have different due dates on Canvas and on my personal website. The only due date on Canvas that's currently correct is homework 1. I just haven't been able to get all the other homework dates adjusted yet.
Oh, okay, great. And the second one is when it comes to turning in the homework, do you want us just to upload the Java files by themselves with the homework document, or do you want us to combine them all into like a, I don't know, a WinZip or a RAR file or something?
That's a good question. Let me ask the TAs about that one, okay?
Okay. And when it
My
comes,
first, oh, go ahead.
oh, I was gonna say, and when it comes to testing our homework code, do you also want us to pass or give you a list of the arguments we used, or is it just the jar files and then you test it as you would with the same arguments from the homework instructions?
Yes, okay. So the question is okay, there were 2 questions here. First one was when you upload your homework assignment, should you upload the files individually or as a single like zip file? And I said I was going to ask the TAs about that one. My guess is they'll want them uploaded individually, just because otherwise there may be a multitude of ways you zip things together and the TAs won't want to have to deal with it. So I'm going to say tentatively, when you upload the answers to your homework assignments, upload the jar files individually. Okay. Second question was when you submit your homework programs, should you provide the test data that you tested your assignments against, or are we using our own test data? And we're using our own test data. Now, if it turns out you get a 0 because it doesn't work, what you can do is set up or go to the TA's office hours or send them email and say, hey, here's the test data I used and it worked. And to try to get some partial credit back, okay? Yeah, we will use test data in accord with, the specifications that we gave you.
Okay, but as for Zoom hours, what if we're working during Zoom hours and we don't have time to actually, or we're not unable to make it to Zoom?
Email the TA in that case.
Okay.
And as of this morning, it's still up in the air as to who the TAs are. I know it's frustrating, but we got some email this morning and it sounded like it was still preliminary. So I will, as soon as I know, I will get you the TAs, okay? And let you know who they are, but we don't know them yet.
Okay, and
So I apologize.
Okay, and final question, I promise it's the last one for now. I read somewhere, I think it was in one of the group or class discords, that if we actually finish homeworks early, we get bonus points or something. Is that a rumor?
No, that's not a rumor. Actually, that was to be the first housekeeping point for today. So the question was, if you get the homework done early and submitted early, do you get extra credit for it? And the answer is yes. So if you submit your homework more than 24 hours in advance of the deadline, you will get 5 points of extra credit for each homework assignment. So this is a great way to get extra credit. It's a way to encourage you to get it in early. And also it helps me because then if you start early, I hear earlier about any issues. So nope, it's not a rumor, it's a fact. Okay.
Yay.
So try to do that rather than submitting it late. A lot better.
Oh, is there no 48-hour extra credit? I thought I read somewhere that said 48 hours, you get 10 extra points.
I think that was in another class, and I'm actually willing to consider that for this class. It's just, this is the policy I've used in the past. I actually am open to giving you 10 extra points if you do it 48 hours in advance. So stay tuned for that one, okay?
Awesome. Thank you.
You're welcome.
It does currently say the 10% if you go to the homework link on this courses page, by the way.
If you go to this link.
Yes, sir.
If it says that, absolutely, I'll do it, yeah. So in that case, absolutely, I'll do it. So you can
Awesome.
take this as the gospel.
You two make great comments and questions.
Pardon?
Oh, I was just saying they ask great questions.
Someone is saying they ask great questions. Well, it helps for me too, because I gotta get that communicated to the TAs. Okay, other questions? I know I've been answering all people on Zoom, but anyone out there? Okay. In that case, what we're doing today and on Thursday is getting you introduced to the basics of Java, and I'm basically focusing on where Java is different than C++. Like, I'm not going over for loops, I'm not going over conditionals because the syntax is exactly the same for both languages, so you already know it. I'm only going over things that are different. And on Thursday, we're going to be talking about enumerated types. So the book didn't talk a whole lot about enumerated types. I know it was assigned in today's reading, but if you go to the lecture notes and you go to My Java Basics and you find enumeration, oh, not there. There we go, enumerated types. There is a link to the Java webpage, and that gives you better information about enumerated types. So you might want to read that before coming to class on Thursday. Okay, but today we're pretty much going to be going over most of the Java basic notes. And on Thursday, it's going to be more about jar files and garbage collection and enumerated types. So it may seem a little bit like a whirlwind, but I think you're familiar with most of the concepts. That it's mostly cosmetic differences between C and C++, or C++ and Java. So the first thing I wanted to start with was actually, I promised you that I was going to explain why when you create a Java program, I basically just want you to put a call to the constructor in main and then put all of the code that you would normally put in main into the constructor. And here's my reason. So I'm showing you first a C++ program. And this is just the first one sums the numbers, the second one multiplies them. And this is how I would write it in C++. And you can see I just would call, sum, and multiply, and it's all good. So if you're new to Java, you think, okay, great. This is what I'm going to do. I am going to write the class arithmetic because I do have to put main into a class. So I'm going to create sum and multiply, and then I'm going to call them out of main. Okay, so actually let me do that. I'm actually going to create that code. Okay, so it's already there. And it's not declared static. Let me get rid of these statics because this is the way you would think to write. So this looks like C++ code, right? Looks pretty good. So you compile it, and the compiler is unhappy. So it says, error non-static method sum cannot be referenced from a static context. What's going on? What's going on is that these two functions assume that they're associated with an object because they don't have the static keyword in front of them. So they assume they're getting a pointer, an implicit this pointer. But they're, when you call them out of a static function is a class function. It does not have a instance of an object associated with it. So when you call sum out of here, it's not passing it any pointer, and so there's a complaint. In fact, you cannot call what are called non-static methods from a static method. Okay, basically the rule is you can only call class methods from class methods. So static methods are class methods. They're associated with a class. They are not associated with an object. So when you put the static keyword in front of a method declaration, it is associated with the class. In fact, it can be, if you make it public, you could actually call it by giving the name of the class dot the name of the method. So for example, if there's a math class and it has cosine, and cosine is declared as a static method, you could do that. Give it the name of the class dot the name of the static method, and it works. Okay? So you can call static methods from static methods, but you can't call non-static methods.
So
So the
I have a
only
question.
Okay, just let me defer you for 1 second, okay? So the
Okay.
fix to this is you could put static here, and you could put static here, and if I compile it, it will work. But it just turns out that remembering to put static everywhere is a huge pain in the neck. So the easier way to do it and to avoid problems is to write it like this, where you just, in main, you call the constructor. The constructor is where you have your calls. Okay, and then you can declare these two methods the normal way. Okay, so this is why the IDEs that you use always do it this way. It just makes life a lot simpler if you don't get caught up in a whole bunch of staticness. Okay, so now I'll take that question.
So if we weren't to declare these as static, we would need to have them associated with like a specific instance of arithmetic. So like we would need to declare an arithmetic object.
So so if you declare them like, okay, so the question was, if you don't declare them static, then somehow you would have to associate them with an instance of arithmetic. And what the answer is, when you do something like you call new arithmetic like this, it automatically creates this instance of arithmetic. And now when you call sum, it's automatically now tethered to this instance of arithmetic.
Okay.
But you can't, if the call, like right here, was from within static, there's no way that you can create an instance of arithmetic and associate it with this call to sum. There's no way to do it.
Okay, I see. Thank you.
Okay, so it's just do it this way, and where you create an instance of the object, and then any main code goes into the constructor. It will just make your life so much easier. Okay. Okay. So we talked about main, how it has to go inside of a class. No variable or method can go outside of a class. Don't worry about .h files anymore. The designers of Java thought that this was another mistake, that separating the declaration of functions and classes from the actual implementation they thought was a mistake, that basically the two should be together so you don't have to flip back and forth between two different files. So in Java, your class declaration and definition go in the same file, which is a .java file. Remember, the name of the file must be the same as the name of the class in that file. There should be only one class per file because Java uses the name of the class to find the file. And if you put multiple files into the same .java file, it won't find the other files or the other classes. Okay, so the rule is one Java or one class per Java file. Okay. One very small difference between C++ and Java is with scope. So here is a program that counts the positive numbers in an array. And it is written in Java. And you'll see that I have I and j declared here. And that in this for loop, I redeclare j. In C++, this program will compile successfully with and no problem. In Java, this will get you a compiler error because they decided, I think rightly, that you should never be able to have a variable declared within the scope of a previous declaration of that variable. So since j is declared here, you may not declare j again within that scope. Now, if it's in parallel, like here, for int I equals 0, by the time you get to this int I, the first for loop has gone out of scope and the I has disappeared. So this is legal in Java because there's no pre-existing declaration of I. But this is illegal. This declaration of j right here is illegal because there's already a pre-existing declaration of j in that scope. Okay, so it's a subtle distinction between Java and C++, but you have to be careful about it. Okay, it is a gotcha. Okay, once a variable goes out of scope, just like in C++, it is undefined, and you'll get an error message should you try to access it. Okay, Java's built-in types. In this course, please use Booleans where Booleans are meant to be used. Don't use ints. And the C++ type for Boolean is bool. Java calls it Boolean. Okay, and Java does actually, unlike C++, if you declare something as a byte, it will be an 8-bit integer in Java. If you declare it as short, it will be 16-bit. If you declare it as int, it will be 32-bit. And if you declare it as long, it will be 64-bit. Unlike C++ and C, where declaring it as a short or an int or a long will get you an arbitrary integer from the compiler. I understand the ANSI what the ANSI standard says. I also understand what real compilers do in C and C++, but it's not in Java. In Java, it is sacrosanct. You use any of these four different declarations and you will get that size integer. Okay, another difference. Java is a lot pickier about its type conversions, and it annoys the living daylights out of me, but it is what it is. So Java will automatically perform a type conversion if that does not entail a loss of precision. So it is very happy if I assign an int to a double because there's no loss of precision. but it will be very unhappy if I go the other way. If I try to assign B to A, that's a loss of precision because B is a floating point number and A is an integer. So it's a loss of precision and Java will not like it. C++ is like, great. Here, let's look at C++. Whoops. So C++, let's do int main, and let's see, there's int A, I believe, and double B equals 6.5, and we'll say that A equals B, and we'll compile that puppy. No, we won't, if we can't save it. Okay, it was happy, right? Even though I was losing precision, not a problem. Okay, let's go and do this in Java. So, naturally, I already have a class, so 1, 2, 3, 4, 5, delete. Int A, double B equals 6.5, A equals B. We'll compile it. Incompatible types, possible lossy conversion from double to int. Okay, so C++, not a problem. Java, it doesn't like it. So how do we fix that and tell Java it's okay? We do what's called a downcast. So we explicitly say, hey, will you please convert that? Now it's happy because we've explicitly made it clear to Java that we know we're losing precision and it's okay. Sometimes you'll hear the word downcast used for this type of type conversion. Sometimes you will hear the word narrowing used. They both mean the same thing. You are deliberately casting down and losing precision. Okay, so sometimes before you go and do something with a downcast, you would like to make sure that it works. Remember, I said Java will type check it at runtime to make sure that it's okay. So it does have the instance of operator, so you can check to make sure, if you're not sure, that it is of a type that you want. So for example, here, if stack is a subclass of linked list, then all of these would be true. B would be an instance of stack, it would be an instance of linked list, and it would be an instance of object. And what it would mean is that you could, this is, let me bring up this for a moment. Okay, so we say that here we have an object, which we'll get to in a moment. We have linked list. And we have stack. And we have two variables, object O, and we have stack S. So in this case, we can always, if we have an object of type S, we can always go this way up the chain. So this is valid, O equals S. Because it's interesting, in some sense, we are, quote, losing precision, but if you know about inheritance, you know that any method that is defined, let's say object defines methods A and B. And linked list adds a new method C, and stack adds push and pop. Okay, so if you know about inheritance, and don't worry if you don't, but in inheritance, a subclass always implements all of its superclass methods. So a stack is guaranteed to implement A and B. So from Java's perspective, it's fine to assign S to O because this variable O is allowed to call these two methods A and B. And it's guaranteed that stack supports those two methods. Now I lose the ability when I assign S to O to call C, push, or pop. Because O, the only two methods defined for an object are A and B. But because it knows that S supports those methods, it allows this particular assignment, and it is called widening, which is kind of a misnomer, right? Because we're actually decreasing the number of methods that can be called. But it is what it is. If I could try to go the opposite way and say S equals O, Java complains. Why is that? Because there's no guarantee that the object that O points to is a stack. It could be, I could have done this. An object might be an array. And I might have actually said O equals new array. Well, in that case, that's kind of a disaster because S is supposed to be of type stack. So you would have to put a downcast here or a narrowing, and you would have to say, cast it to a stack. And in fact, because O is not a stack, you will get a runtime exception from Java. Okay, so this operation, again, is called narrowing. So you can widen by assigning an object to a more general type of object, like assigning stack to an object, but you can't go the opposite way. Okay, questions about that? Okay. So moving on. Arrays. So this will be the first time, this will be one of the first things that will be a major trip up for you. I really need to get a mouse back. Got a mouse? There, we got a mouse. Okay. Okay, arrays. Arrays are not primitive types. In C++, an array is a primitive built-in type. In Java, an array is an object. And in Java, there are no stack allocated objects. Objects are only allocated on the heap. Okay, what do I mean by that? In C++, I could have a class stack. And there are two ways I could declare a stack object. I could say stack S, or I could say stack asterisk stack pointer equals new stack. Okay? And in C++, this one is called a stack allocated object because it will be allocated on the stack. Okay, so if you look at the stack, this is main, then there will be a stack object here for S. Whereas for SP, it will be a pointer to a stack object. This is called heap allocated because it's allocated off of the heap using new. In Java, there are no stack allocated objects. Objects are only allocated off of the heap. So in Java, if I say stack S, like that, what I get is a null pointer. S is a null pointer. Okay, the only way to instantiate it is to say S equals new stack. And then it will point to a stack allocated, a heap allocated object. Okay, so every object in Java heap allocated using the new operator. It doesn't come automatically. You have to call new. Okay, that brings us back to arrays. Arrays are objects. Therefore, when you declare an array, you do not give the size of the array, because all you're doing is declaring a pointer to a one-dimensional array. And you will have to say new, like here, in order to allocate an array object off of the heap, in this case with 6 integers, and that you will be assigned a pointer. Okay, so when you declare an array in Java, what you are really doing is declaring a pointer to a one-dimensional array. You can do it this way too. I shouldn't say I have no idea why they did it this way. I have every idea why they did it this way. So for those of you who are mathematically inclined, this is pure because the entire type is together. Okay, this says it is an array of integers. This is not pure because the type information is both before and after A. So this is why the people who love their type theory also made this a valid array declaration, because it keeps all the type information together. I don't care what way you declare them. I've never seen anyone declare them this way. Okay, so, but I don't care. If you want to declare it that way, you can. The important thing you understand is that when you're done with these two declarations, you have 2 null pointers. Okay, so just to drive this point home, let's go up here and declare int a and try to do something. A sub 1 equals 10. Java C, foo.java, error. Variable A might not have been initialized. No kidding. It's a null pointer. You say, okay, hey, Brad, why don't you just do that? I don't believe you. I think I can do that. But you can't. Lots of error messages. Error. Right bracket expected, not a 1. Error. Illegal start of expression. Nope, no can do. cannot declare those puppies. However, this is going to be all over this. Now we're good. Happiness. So you got to declare your arrays. Okay. So you think, okay, I'm good. Oh, by the way, you can also declare your arrays this way using C++ initialization syntax, and then it will automatically allocate an array with that number of objects. Okay, moving on to common error number 2. We have a class called person, and we create an array with 10 new persons, and then we try to assign to here. Let's take a look at what happens. So let's do that. Up here, let's create a class person, and we'll just give it a string name. Call this person. And we'll assign Brad, cs365sp21.name. Make sure I can do this out of a static method. It may not like this out of a static method. We'll see. I didn't like string because it's a capital S. Okay. It liked it. It compiled it. Let's run it. Ooh, exception in thread main java.lang null pointer exception. Line 8. Let's check out line 8. Whoa, wait a minute. This can't be the case. I declared 10 new persons right here. Well, what I got was an array of 10 pointers to persons. So when I did this, what I really got was an array from 0 to 9 of nulls. Each of them is a pointer to a person object. But I didn't allocate them. Remember, everything is allocated off the heap. So in C++, if I say person star p equals new person 10, what I will get is 10 person objects. What I get, so this is C++, this is Java. In Java, I get 10 person pointers. In C++, I got 10 person objects because they were okay, they weren't stack allocated, but I got 10 person objects. So the reason I got that null pointer exception is because when I allocated 10 new persons, I got 10 nulls. So when I went and tried to get a1.name, ace of 1 was null. Hence, a null pointer exception. Which is nice, by the way, because at least Java immediately tells me where the problem was and that it was a null pointer. So it's a little nicer than C++. So what's the fix? Before I do that, I'd have to say something like for int I equals 0, I less than a dot length. Don't say less than 10 because in Java, because arrays are objects, they carry properties like their length. So I can actually say that, and now I could say a sub I equals new person. Okay, and that should make, it will compile. No, it won't. Okay. See, this is why I recommend you put everything that you want in main into a constructor, because inevitably, eventually, you're going to start getting this non-static and static stuff. Okay, so I'll just make my life easy, and I will copy this 1, 2, 3, 4 dB, and let's make it a foo. Put that there. And I'll just call new foo from here. That should make it happy. And now I can run it, and life is good. And that is because I took care, after I allocated the array of 10 people, to actually go ahead and create 10 instances of person. Okay, so this takes a lot of getting used to. I can almost guarantee that I still will get at least one question on the first homework assignment asking why I'm getting no pointer exceptions when I try to write this code, but I'm trying to head this off as much as I can by emphasizing it. So arrays are not primitive objects or not primitive types. They are objects, and you have to allocate them off the heap. And if you have something like this where the array is an array of classes, they're actually an array of pointers to those classes. Okay, questions? Any of my Zoom people got questions? Okay, I'll move on. So you can declare multi-dimensional arrays. You just indicate how many dimensions you want. You can either then declare the multi-dimensional array all at once, or as in C, you can say, okay, the first dimension is I get 4, and then after that, I want to control for each of the arrays I get back, I want to control their length. So I want them to be different lengths. And a nifty construct for iterating through the elements of the array is the for construct. So if you don't care about the indices, index values, all you care is that you want to iterate through the array and do something to each element of the array. There's this for construct. You give it the name of the variable that will get the value of each element in the array, colon, the name of the array, and then each element of the array is assigned to this variable in turn. This is important. You can't declare this variable outside of the for loop. I don't know why, but you can't. It has to be declared in the for loop like this. If you try to declare element out here with some, if you said before the for loop, you said int element, and then you just said for element, it won't work. I don't know why they designed it that way, but they did. So if you use the for loop, the variable you declare here has to have the type of the array element before it. And then it will go out of scope afterwards. Okay? So that's it for arrays. Now we're moving on to classes. So unlike in C++, in Java, there is a root object called object. Any object you create, like list, if you don't give it a superclass, it has a superclass, and that superclass is object. So in Java, every class that you declare has a superclass. Okay, if you don't provide a superclass, its superclass is object. Okay, now object has a few methods associated with it. Let me move this around. So I always end up Googling object Java. I know this is the 7 and not the 8, but it's good enough. So all objects have a certain set of methods associated with them, like clone that copies equals. Remember the equals method for a string that you have to use. You get toString somewhere here. Whoops, where's toString? Wait, there we go. toString, which converts the object to a string suitable for printing. These other things are concurrency, which we'll get to when we get to concurrency at the end of the course. Nice thing, all objects will automatically compute a hash code for you. So that's a built-in method. You can always get the class of the method, don't worry about it. And then there's this finalize method, which is like the destructor in C++. We'll get to the destructor in a moment. But you see, all objects, the big things are finalize, equals, and toString. So what's nice about that is that the fact that every object has a superclass is that it allows you to declare generics. Like with a list, I can actually say insert after, and I can then make that list store any possible object by just declaring it as object. Because remember, Java is happy with widening. I can assign any object to a variable of type object. Not a problem. Now, when I get things out of this list, I will have to downcast. But the neat thing about having object at the top of the class hierarchy is I can declare generic objects like this, and I don't need templates. So originally, Java did not have templates because they thought they were a mess. In fact, I think the word hot mess was used, but they hated templates. And they went with this approach, which they eventually realized was a mistake, and they went back to using templates. They realized that downcasting led to its own set of problems. But originally, the idea was we wouldn't need templates. We just have this object at the top of the class hierarchy. We could declare generic data structures like list, stack, and the like, and they could store any type of object. Now, an obvious problem is primitive types aren't objects. So one thing that quickly became apparent was you couldn't store a list of ints or a list of chars or a list of bools because they weren't objects. So then they developed wrapper classes so that you could easily create what were called boxed ints or box bools, and we'll get to that. Don't worry about it. When we get to generics, we'll talk about all that. But at any rate, just know that object is the superclass of any object like list that you do not explicitly declare a superclass for. Okay. Java does not have a concept of pointers, meaning in C++, you can declare something with an asterisk in front of the variable, and that makes it a pointer. That's what, when people say Java does not have a concept of pointers, that's what they mean. No pointer arithmetic, no declaring something as a pointer. So then people get confused because Java is all about pointers. Okay, every object variable you declare is actually a pointer, right? And you have to allocate something off the heap that it points to. So in fact, all object references in Java are pointers. However, you always use the dot operator to access fields of an object variable. You never have to worry about the arrow operator. So here, stack A, stack B equals new stack, B dot push. Okay, now I say A equals B. And what happens? What happens is A points to B. So in this code, what happens is we declared A to be a stack, and it's null. And then we said B equals new stack, so it points to a stack object. Then we said B dot push 3, so 3 got pushed onto the stack. Then we said A equals B, and this is what happens. A gets assigned the pointer to B. So when we say now A dot push 5, it turns out that it appears we've pushed 5 onto B stack. This would not happen in C++. In C++, what would happen is when we executed this equal statement, it would have made a copy of B and assigned the copy of B to A, so that when we pushed 5 onto A, we would have had 2 separate stacks. One stack A with the contents 3, 5, one stack B still with the contents 3. So what you got to get used to in Java is that these kind of statements assign pointers. These are shallow copies, not deep copies. Okay, shallow copies are pointer copies. Deep copies are when you copy the value or the contents of an object. In Java, equal is a shallow copy. It copies a pointer. Okay, so a lot of you will be confused. And so I have this example of a linked list. And you can actually walk through the visualization to kind of see what's going on. So a lot of students get freaked out because they say, okay, Java doesn't have pointers. How can I create a linked list if I don't have pointers? So in my notes, I have an example, and I want to show you what's going on. So here's a class MyList, class node with string name and node next. And then I have a string of arguments, Brad, Yifan, Smiley. I set my head to null, and I have a way to create a new node. And then I iterate through my argument array. For each string, I create a new node. I assign it a name. Then I set its next equal to the current head. And I set the head equal to new node. What I want to do is execute this code so that you can see it in action. So we start down here creating an instance of MyList. And that creates a call to this constructor. And here's main with its stack. So it has a this pointer, and it's pointing right now to this new instance. So now I come down and I have this array. So you can see that in this instance. So here's main. Now on the stack is, so main, here's my stack frames. Now I have this instance that's the pointer, and now it has this array, and it points to this array object. Now I'm going to set head equal null. So head is set to null in this object. Now I'm going to iterate through the argument list. So it sets name to be Brad, which is the first name. And now we create a new node. So that creates a new object of type node. And we jump up here to class node, to the constructor. And nothing is in the constructor. So we simply return immediately with a return value of void. And we come down here and we now have new node is not yet pointing to it, so it hasn't yet done the assignment. But there, next step it has, so new node now points to this new instance. And we're going to assign name to name. So it just became equal to name. And we're going to assign the next field to be head. Head is null, right? So it stays as null. Now we're going to set head to be equal to new node. So head now points to the new node. It's the first node in the list. Okay, so now we're going to come back up here and we're going to insert yifan, and yifan's going to become the head of the list. So we're inserting at the front of the list. So name becomes yifan. And we come up here because we're creating a new instance of node. And we come down here, back down, and now new node points to this new instance we created. We'll assign yifan. So new node.name equals name gives us yifan. Now, new node.next equals head. So now we're going to make yifan point to the head of the list, which is Brad. So now yifan points up to Brad. And we now set head equal to yifan. And we have a list with two elements. So if we follow head, we come to yifan. If we follow the next field, we come to Brad. So feel free to, that visualization is available in my lecture notes. You can go through it. You can actually go backwards if you want with the previous. So you can see what's going on. You can go backwards and forward. So it's pretty nice. Okay, in fact, this program is called the Python Tutor. If you're having trouble visualizing what's going on in your Java programs, it's a free tool. And you can type in short Java programs. It executes the program and it basically creates a little time strip where you can go forwards or backwards one step at a time to visualize what's going on. It's pretty handy. It won't work for big Java programs, okay? Just small ones, but when you're getting started, it can be pretty handy. So questions about this linked list program? You can see how we're able to create a linked list.
I have a question about shallow copy versus deep copy.
Yes, okay, go ahead.
So is the convention to use the superclass clone method or to create what is essentially your own equals operator
Yes,
overload for classes?
exactly. So the question was, if you want to create a deep copy, how do you do it? And the answer is, the person suggested use .clone. So if you want to create a copy of yourself, so back here, not there, not here either. I hate this. Okay, so now it's just like, great, I click to that site and now it's not going to let me go back to my site. Like, why should, I love how sites trap you and then won't let you go back. Of course, all my bitching and moaning about it achieves nothing. Okay, so here, right here, if you wanted to create a copy of B, you would have said A equals B dot clone. And that would create a copy. Now, that assumes that you have defined a clone method. So the clone method is like the copy constructor. So if you're wondering, does Java have a copy constructor? The answer is yes, it's called clone. So if you want to write a copy constructor, you write clone. So guess what clone does? It also does a shallow copy. So you have to be, by default, it also does a shallow copy. So you got to be careful, just like in C++. In C++, if you don't define the copy constructor, it also does a shallow copy. Okay, it just does a byte by byte copy. So generally speaking, you want to define the clone method, just like in C++, generally speaking, you want to define the copy constructor. Okay, does that answer your question?
It does. Thank you very much.
You are welcome. Okay. So just again to emphasize, all objects have an equals method. Don't go comparing two objects using the equal operator. I said it last time. I'll say it again this time. Java does not have operator overloading. So the way that C++ achieves the value comparison between strings or objects with equal is it's overloading the equal operator. Java does not allow operator overloading. So equal will always do a pointer comparison. So if you want to compare based on the values of two objects, use the equals method. It's defined in object. Now by default, what do you think equals does? A shallow pointer comparison. So by default, it will just do a byte by byte comparison. So again, you typically need to define those equal methods. Okay, but you'd have to do that in C++ too. The reason the string equal operator works in C++ is someone wrote the method for you. Okay. So other differences between Java and C++. This isn't a difference anymore if you're using a recent version of the C++ standard. It used to be that you could not initialize your instance variables in C++. The most recent versions of the C++ standard allow you to. So it all depends on which compiler you're using and whether it implements it or not. But in Java, you are allowed to initialize your instance variables when you declare them. They are initialized before the constructor is called. Okay, so in C++ has an equivalent notion. Remember initialization lists? Do you all know what I'm talking about when I say initialization lists? Maybe, maybe not. Okay, in C++, you're allowed to say, in a constructor, you're allowed to say something like person, say string n. Actually, and you could say something like salary 0. This would be called an initialization list. Salary would be set to 0 before the constructor is called. Java doesn't have initialization lists because you can instead just do it there. Now, Java also has a neat thing called initialization blocks, which in the body of the function is simply, it looks like a procedure in that you have braces, but there's no, it's just code between braces. So if you see a class in Java and you see some code between braces but no method name, That's called an initialization block. It gets executed before the constructor as well. Execute it before the constructor, but after these instance variables have been initialized. It is nice because you often find yourself calling a zero argument constructor in C++. And you might have 5 constructors and every single one of them has to call the zero argument constructor. So Java said that's bad because if you're maintaining the code and you add a 6th constructor, you may forget to call the zero argument constructor. Why don't we just provide an initialization block that acts exactly like a zero argument constructor and is automatically called as opposed to forcing the programmer to explicitly call it. So that's what this is. If you ever in a Java class see some code between 2 braces like this with no method name in front of it, it is an initialization block. It is a zero argument constructor called before the constructor is called. So obviously you can't pass anything from the constructor into this initialization block. Okay, so here I'm just creating 10 random numbers and assigning 10 random values to them. That's something I want every constructor to do. Okay. Okay, in Java, so moving on, in Java, if you want to create a class variable, you preface the declaration with the word static, and that means that that variable no longer belongs to an instance, but is shared by all elements of the class. All instances of the class will share that variable. So instead of color now being in each instance of this class, there's only one value. It's shared by all. Okay, you can have static blocks. I almost never have them, but static blocks, so you would see static, just like you can have static, just like you can have a initialization block, you're allowed to also have a static initialization block, and it initializes static variables. So should you have to run some code in order to initialize your static variables, you use the keyword static, and then you have an initialization block. That will run once when the class is loaded. Okay, by the way, Java loads classes dynamically. The first time you create an instance of a class, Java's loader is the virtual machine calls the loader and it loads the bytecodes for that class. It's on demand. Now it's allowed to prefetch, but essentially the Java virtual machine works on an on-demand thing. So the first time you say new person, it goes out, finds the class file for that class, loads it, executes the static initialization block, initializes the static variables. Okay, access protection. So in Java, they're the same right now. We'll get to why they're different later, but right now there's public, protected, and private. Work exactly the same way. The difference is in C++, you can say public colon, and everything after that will be public until the next access modifier. Not true in Java. In Java, the default is private. Okay, it's not really, it's package level, but for the time being, accept this white lie and accept it as private. So if you don't put an access modifier in front of your declaration, it will be considered private. So if you want it to be protected or public, you must put the keyword in front of it. And believe me, this will bite you probably at least a dozen times this semester. You will forget to put public in front of it and you'll get an error message and you will grind your teeth. But it is what it is, okay? So, okay. Destructor. In Java, the destructor is called finalize. It's also a zero argument method. It is also void. It is called by the garbage collector when the object is finally destroyed. Listen up. Never, ever call finalize yourself. Never. Okay? I made that mistake when I was a novice Java programmer. Here's the issue. Finalize is typically used to release resources. Well, if you call finalize and it releases the resource, and later the garbage collector calls it and it tries to release the resource, guess what you get? An exception because you don't own those resources anymore. So don't ever call finalize. I made the mistake. I'm telling you, don't do it. It will be automatically called by the garbage collector. Now, here's the wrinkle. Sometimes it turns out Java can't garbage collect the object unless you call finalize, unless you close certain things. So the problem is you sometimes get in this vicious cycle. You can't call finalize because only the garbage collector will call finalize. But unless you do some closing of things like files, it's possible the object will never get garbage collected. There are things like circular references and the like. So if you need to ensure that resources get released, instead of putting them in finalize, put them in another function like close, okay? And release the resources there. Because there is no guarantee that finalize will get called. The garbage collector is not infallible. It sometimes will not garbage collect objects and then finalize doesn't get called. So that's my word of warning. If you want to ensure that resources get released, don't put those calls into finalize, put them into a separate function that you explicitly call when you're done. Okay? Nested classes, I think, are pretty easy. Last thing, the final keywords, the way you create constants in Java is not with the keyword const. Guess what? Const is a reserved keyword. I have no idea what they reserve const for, but it's not used to declare a variable as const. Final is. So if you declare something final, that is the same as declaring it as const. You put that in front of an instance variable, it becomes a class variable. Okay, so if it's done, if you do this in a procedure, it becomes a constant in the procedure. If you do this as an instance variable, it becomes a class variable. Okay, so that is it for today. We discussed parameter passing last time. So Thursday, jar files, enumeration types, and garbage collection, how it's actually done. I will see you Thursday. You should be able to get started on some of the homework. I will get the homework dates fixed. Okay, so I'll see you Thursday. Questions? Anyone on Zoom got a question?
Would be asking too much to after the class or everyone leaves if you could look over one of our link lists or one of my link lists, just make sure I did it right, just so that way whoever's grading looks at it and doesn't wonder what the hell is this.
Yes. Mm-hmm.
Okay, thank you.
Anyone here have a question? No. Okay. Anyone else? Oh, have a question? Yeah, go ahead.
I think you mentioned someone asked us at the beginning of your class, but will you send us updates on how the TAs want the homework submitted and everything?
I will. For the time being, assume that if you're submitting now because you got it done, just submit them as separate files.
Separate file. Okay, awesome. Thank you.
You're welcome. Other questions?
I had a quick question regarding the quiz